Okay, I think according to some of my students and also to myself, this is one of the most ugly and annoying questions. Please, as ever, take your time, have a look, and then hopefully you'll agree with my explanation. Okay, this is one of these ones, like I say, that, yeah, I'll be honest with you, I think when I first worked through it, I completely overcomplicated. I ended up making a simulation of it, etc., etc., etc. It's very complicated in terms of what's going on, but once you can see it, hopefully it makes sense. Now, the way that I would do this is as follows. Now that I've thought about it, is think about this. Our wires are firstly ideal, and so they are going to connect points of equal potential. So let's imagine the potential here at X is here. Anything going in here is going to be at potential X, all right? And so that means that this point here we have potential X. Okay, we then follow this wire. It's connected by a wire of 0 resistance, and so it also means that this point here is at the same potential. Now that seems completely boring and uninteresting, but just hold with me for just now. We're going to do the same on the other side. We're going to go this way. Anything here is going to have potential Y, which means that anything joined to it is also going to have potential Y. Now hopefully what you can see now is that we have potential differences. We've got potential difference between this point and this point is Vx take away Vy. If we then compare this point here, potential difference take away here, potential take away potential here is Vx take away Vy. And then finally, we have potential here Vx and Vy here, Vx take away Vy. We have 3 components with the same potential difference. In other words, these guys, although they may not look like it, they are connected in parallel. Parallel circuits say that the potential difference is the same across all of the resistors. So effectively, they are in parallel, and so as such, we can add together their resistances in parallel. 1 over RT is 1 over R1 plus 2, 3, which gives 3 over R. In other words, RT is R over 3, which is 2, which gives you 2 ohms. Now, I completely appreciate I've done that very quickly. I did have an alternative way of doing it with a FET simulation and loads of other ways, but this is really just the definition there, that we're applying the definition of a parallel circuit, which is that the potentials are the same, potential differences are the same across each of the branches, and by connecting them with these 0 resistance wires, that's exactly what we've got. Vx take away Vy is our consistent potential difference.